Today's show is sponsored by Datadog, a cloud-scale monitoring platform that unifies metrics, logs, and traces from technologies like Istio, AppMesh, and Envoy. Plus, Datadog's Service Map automatically plots out the dependencies in your microservices architectures for seamless, context-rich troubleshooting. With rich visualizations, algorithmic alerting, and more than 250 vendor-supported integrations, Datadog allows you to monitor your distributed applications in real time. Start a free 14-day trial today by visiting datadog.com/cloudcast. And Datadog will send you a great free t-shirt. That's datadog.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. We continue to move along through May, kind of getting into the middle of May. Hope everybody is doing well. Hope everybody is staying safe and hopefully getting healthy and maybe in some cases getting back to normal a little bit. So take care of everybody out there. Take care of your family. Let's jump right into Cloud News of the Week. A lot of money moving around this week. Couple of interesting acquisitions, or not so much acquisitions, sell-offs, and a couple of acquisitions and some money moving around. So let's get started. First off, Dell is selling off their Boomi iPaaS platform. Dell, kind of an interesting product to be in the Dell family for a long time. Dell very much focused on hardware and infrastructure, owns VMware, owns EMC and all that. But they own this company called Boomi, Boomi, that was in the iPaaS space and actually did quite well for quite a while. Was always highly ranked in things like the Gartner Magic Quadrant for iPaaS. But as Dell tries to restructure their financing, obviously they announced a spinoff of VMware coming up soon. They're selling off the Boomi iPaaS to Francisco Partners and TPG Capital for $4 billion. So bringing some money back into the Dell coffers allows them to get down in their debt space and really start looking at what they want to be as they spin off some of these other acquisitions. The second one, sort of interesting, maybe not so much cloud, but for anybody who's been around the internet for a while, Verizon is selling off both Yahoo and AOL for $5 billion, again, to private equity. What's interesting about this one, maybe not so much the AOL piece of it, although some folks still have AOL addresses. For those of you that are younger, go look up AOL. It used to be the internet. But Yahoo is very interesting because Yahoo is actually probably I believe, if I read correctly, the fourth most trafficked property on the internet still. So, behind folks like Google and Facebook. But so a highly trafficked property that is highly undervalued or under-monetized. So that'll be sort of an interesting thing to watch. But Verizon, as often happens with telecommunications companies, they decide at some point they want to get into the media business. They want to do more than pipes, but then they eventually oftentimes get out. So it'll be interesting to see sort of what happens now with Verizon as they sell off that business and where they go next with all the 5G work they're doing. Third thing we had on our list was that ServiceNow bought Lightstep, a company who really was kind of pioneering some of the early work around observability. Obviously, there are many other companies in that space, Datadog, Honeycomb, Observe, New Relic, lots of others. But ServiceNow adding observability to their well-known sort of service catalog or service maintenance type of business. And then finally, in a trend that we're seeing quite a bit, I don't know if it's a great trend or not, but we're seeing a lot of companies taking late round fundings, round E and round F. So Circle CI, who very, very popular in the CI space, offers what's typically considered a fairly simple to use CI system, took a $100 million F round. So this is the last couple of rounds have been $100 million rounds. So they took another round of funding. It's always interesting to see what happens as companies continue to take this, why they took another round of funding and instead of trying to go IPO, are they setting up for something bigger? Do they still think there's an IPO in their future? But Circle CI, congratulations on the new round of funding. And, you reach a point where, you're probably going to have to sort of redefine the business at that point. So with that, I'm going to wrap up. And, like I said, a lot of money moving around, whether it's selling off or acquiring or raising new funding. So always kind of be the case here in the cloud. It's always good to see that much things happening. And with that, we're going to wrap up. And we will get into our show right after the break.
Today's show is sponsored by Okta, the leading independent identity solution. Okta provides best-in-class authorization so your customers and workforce can safely access what they need most right when they need it from anywhere. Organizations around the world trust Okta's Identity Cloud to sign in, authorize, and manage users, whether it's employees, contractors, partners, or customers. And with Okta's developer tools, you'll never have to build authentication again. Our customizable code blocks are flexible and future-proof with easy-to-use APIs and SDKs, so you can do less coding and more shipping. Okta is dedicated to building the most reliable, neutral identity platform because it means protecting more than a login. Identity is protecting people, their ideas, their work, their brilliance. It's protecting your future with confidence. Learn more at okta.com. That's OKTA.com.
Today's show is brought to you by CBT Nuggets. You know how much we value ongoing education on the Cloudcast, and CBT Nuggets is exactly what Aaron and I wish we had when we were trying to get our certification early in our careers. CBT Nuggets is all about bringing a personalized touch to learning about cloud computing, virtualization, networking, DevOps, and much, much more. Whether it's their hands-on labs with personalized coaching or the online chat functions that come up with every instructor-led course, CBT Nuggets' team of experts is always there to help you get the most from your training and your path to certification. You can check it all out at cbtnuggets.com/cloudcast and sign up for a free trial. You get access to the full catalog of great training, including virtual labs, quizzes, and other premium features completely free for the first 7 days. That's cbtnuggets.com/cloudcast. And we're back. And folks, you know, as anybody who's listened to the show for a while, you know that we always bounce around between a lot of different topics, but sometimes, you know, there are some trends that we like to follow up on and things that we like to dig into. And it's always a fun intersection for us when we get a chance to not only kind of follow up on a topic that people have given us a lot of feedback on, which is things like event-based applications, event-based streaming, Kafka, which we talked with James Urquhart earlier in the year about. And then whenever there's sort of new technology that's going to scratch the itch of the technologists out there and people that love new things. So really excited today to talk about kind of a new concept, a new technology that we think we're probably going to see and hear quite a bit about. We're going to talk about something called ksqlDB, and excited to have Michael Droglis, who is Principal Product Manager over at Confluent, the folks who everybody knows with Kafka. Michael, welcome to the show.
Thanks for having me, Brian.
I want to dive into this because you had reached out to us. Obviously, we've talked about Confluent somewhat, Confluent somewhat, Kafka somewhat, probably not enough given kind of how prevalent it is in the industry. And you had reached out and you said, hey, we're working on this really new, cool thing. Before we dive into that, though, give us a little bit of your background, because you've had an interesting mix of being hands-on as a developer. You've been an entrepreneur. You're now on the product management side. But give us a little bit of your background before we dive into ksql.
Yeah, absolutely. My story, I guess, starts back in 2014 when I graduated from college. My last year of school, I was really into distributed systems. I had a professor who was really near and dear to his heart, and so I got a really healthy dose of that. I thought that was really neat. And when I came out of school, everybody who I thought was cool seemed to be doing open source projects. And I wanted to be cool too. So I also started an open source project. And the thing that I found that was kind of neat was stream processing. It was at the time, in 2014 or so, this idea of streams of data was actually starting to become something that was really integrated into more people's architectures. And they were sort of just figuring out, how do you work with it? How do you write programs against it? How do you write programs that are useful and correct and fault tolerant? And it was just really like an open problem set. And so, the thing that I did was start to build out an open source community called Onyx, which was a stream processing platform primarily targeted at the Clojure programming language. Still really into functional programming, have been for a while. And that was really fun. It's a project that really looked at how do you write streaming programs in a completely different way. They're using mainly data-oriented programming.
Okay.
And that was successful enough to start a small company named Distributed Masonry, where we did a couple different things. But the thing that we were most successful at was building a new product on top of Onyx called PyroStore. And PyroStore was a streaming native data warehouse for Kafka. And so the simplest way to explain it was kind of like you have an S3 backend for Kafka, where data is actually processed in as a stream, and you kind of have an S3 type backend for Kafka, where you're able to not only access the data in a streaming manner, but also to query it with like regular batch tools. And so that became successful enough for Confluent to acquire us in 2018. And it became the basis for something known as tiered storage, which we could talk a little bit about later. But after being at Confluent for a bit, I've kind of come full circle again, and I work on something called ksqlDB, which we're here to talk about. And I've come all the way back to stream processing. So it's kind of a there again and back story.
Yeah, no, that's very, very cool. It's sometimes it's you're passionate about something. The timing of it is maybe slightly off from where it needs to be, or it was not the right place, but maybe not exactly right. And it's cool that technology sort of goes in these waves that you can come back into it. Before we dive into it, let's talk a little bit about Kafka, just so we can set some baseline for people, because that's at the core of what you're interacting with. So for anybody new to it, like, what is it? Sort of at its core, what does it do? And maybe what are maybe kind of a canonical use case or something that people would be like, oh, okay, that's where it interacts with things. Like, that's something I can relate to that an application would interact with.
Yeah, Kafka is something called a distributed event streaming platform, which is a lot of words, but it's actually pretty easy to break down. There's many parts of the project, but the main one is a distributed commit log, which is really a storage engine for events. And I think the next good question is like, well, what is an event? And an event is any kind of piece of data that happened. There's lots of events that happen in the world. If you have customers who are browsing your website, every page view is an event, every button click is an event, every purchase order is an event. It's a very fun concept because you can kind of imagine, down to the smallest granularity of like physics, what are events, and you can become more and more philosophical about it, and you get more and more utility the more fine grain you go. But what Kafka gives you is a place to record those events, and it gives you a way to do that where you're able to capture the order that they happen in, and that ends up being like a fundamental thing. If you want to make use of the data, you need to know what happened and in what order it happened in. And so Kafka gives you these storage primitives called topics, where you basically have immutable data. You write what is happening to the topic or to the log, and it's recorded immutably. You can't change it. And again, this is really useful from a programming perspective in that once you put something into the log, nobody can mess you up. It's just sort of recorded for history. And the thing that makes Kafka really unique is that you're able to have multiple subscribers to these topics of events. And so I can subscribe to the data, you can subscribe to the data, we can be at any part in the log. There's no destruction of these events, and so you can read any part that you want. Again, no one's sort of going to trip you up, and so you have this really, really strong decoupling. And this has kind of been the basis for why people really like to put Kafka at their company, is that you have this like total isolation of different teams and different use cases, and yet you can safely share information. And so this comes up a lot. Companies adopt it for pub/sub, publisher subscriber patterns, where you want to broadcast information to a company. It's quite useful for data transfer, where you're trying to move data from like one database into like several other warehouses as sort of an internal buffer. And then stream processing is another huge use case, where you're actually trying to take action on these events as they occur in real time. And to me, that's really the most interesting and sophisticated use case.
Yeah, and that's the one that I tend to hear about the most, as to, why you might use it, net new versus some other type of existing database. It is interesting that you talk about it as being sort of a data, transport thing as well. Like, you can think of a number of interesting use cases for that. So it handles all these streams of data. People can subscribe to them. To a certain extent, it's replacing of sort of old like enterprise service buses where everything had to be well defined, well maintained, and so forth. And then you're going to obviously connect those data sources to some sort of application at some point. Like you said, there's a number of pieces to that project, but there's also, if I think of kind of the completeness of how somebody might interact with it, right? There's going to be, their application. There's probably some sort of transformation that has to happen with the data, because I believe Kafka just sort of takes streams. It's not doing it some sort of ETL function. What are some of the common sort of pieces that live around Kafka? And then maybe what are some of the challenges that people often run into, in building these systems?
Yeah, you have it exactly right. Kafka is so scalable and so useful. And so performant, because it actually is so simple. It's really just taking the raw bytes that you give it, and it's storing them in an ordered log. And as useful of a primitive as that is, it's actually not enough to be able to easily build an application. So the thing that I always have in my mind is, how do we make it easy enough, like Ruby on Rails, for people to build apps that are actually using this data in real time? I feel like if we could get to that level of simplicity, then we really, achieve something as an industry. And so if you kind of look at what Kafka gives you and what's missing, I think there's a few things that go into building applications. The first is data acquisition. How do you actually get events from the place that they are born and move them into Kafka? A lot of people start imagining what it would be like to work with an event-driven architecture, and they skip this piece because it just feels like it should be a totally solved problem. And then you kind of actually have to go do it, and you're like, oh, I have to go, build out those pieces myself, and it's a bit unexpected. And so this is the domain of something called Kafka Connect. It's part of the larger Apache Kafka project. But what Kafka Connect gives you is a framework to be able to define these connectors where you write the specialized code to talk to different target, source, and sync systems. And this is incredibly useful because there's so much common complexity. There's thousands, tens of thousands of different systems that you can talk to, and they all have particular ways of how they want to send data or how they want to receive data. So data acquisition as a whole is just a really challenging thing, and it's an interesting part of the project to watch evolve. The second piece is stream processing, which is, as I mentioned, how do you do something with these events as they show up in real time? One analogy that I really like, when you sort of contrast, working with your data from like a database perspective versus a stream processing perspective. When you write a database query to like process some data, it's kind of like solving a puzzle. And with a regular database, you're given all these pieces, but you really can't see the face of the puzzle until you fit all the pieces together. It's almost blank. But when you snap the last piece together, the face of the puzzle reveals itself. The puzzle pieces are, of course, the data, and the face of the puzzle is the query result. You're just sort of waiting for it to finish in a request response style. But with stream processing, you're just given a piece at a time. You don't get, all the 1,000 pieces, and you don't get to pick the four corners, and you just take the pieces you're given and you most intelligently fit it into the puzzle. And it's harder, but the payoff is that the intermediary states are obviously incredibly useful. Just like a real puzzle, you're watching the face of the puzzle unveil over time. Right. And so there's lots of use cases for actually just being able to use that. And the last piece that's pretty challenging and is not at all solved by the Kafka project in any capacity is querying your data. So you're able to sort of materialize these views, if you like, as I described with stream processing. You're aggregating data over time, but how do you actually ask questions about this materialized data? And you end up in these interesting situations where you're trading off the complexity of running queries against these views versus the simplicity of just trying to get the view into the right form to query it really quickly. And so, all three of these things are like major challenges. Some are solved by the Apache Kafka project, some are not. And they really form the foundation of like what's left to build.
Right. And I think that is sort of probably the perfect lead into what we're really going to focus on today, which is ksql database or ksqlDB. What is it? Right. It's as I sort of read into it and dug into it. It's real time. It's Kafka. It's SQL as a query language. But kind of walk us through. You're at the center of this project. Like, kind of what's the thinking around it, and what parts of those challenges is it trying to solve?
Yeah, everything we've talked about so far is pretty low-level distributed systems internals, data acquisition, processing, query execution. Those are it's very cool in the sense that it's like a neat thing to want to study and dabble with in open source. Or maybe if you really want to specialize in this, you can. But it's probably not something that people want to be thinking about and doing on a day-to-day basis. And so, as I mentioned, I think if people want to harness real-time data and these streams of data, they actually need to have something much simpler. And so we really wanted at Confluent just to have a much easier way for people to be able to harness this. And I think databases, in particular relational databases and SQL, have been an incredible abstraction so far. They actually bundle up all of the details of storage, query execution, concurrency control, crash recovery. There's a whole lot of things that are hidden behind SQL that you never have to think about. And so what we're really trying to build with ksqlDB is a new kind of database. We call it a streaming database, in that it's sort of like a classic database flipped on its head, and it does everything in a streaming native manner. And so with a classic database, as I said, you put your data in, you have your data at rest, you query it, and then when the query finishes, you're actually able to get the results. What's actually much more useful in a streaming database is to sort of pre-install these more persistent queries. Data is constantly flowing into your database. It's constructing these tables of view tables of data as soon as your events are received, and then you can query these materializations whenever you want, either in a streaming manner or a request response manner. And so it really tries to flip the whole model on its head and give you all the tools that you need: data acquisition, stream processing, querying, and storage through Kafka, to be able to work with your data as in a real-time manner.
Yeah. So as you're explaining it to me, and I'm kind of thinking about this, obviously, using SQL as a query mechanism, like you said, it builds this sort of native structure. Plus, there's just thousands and thousands of people that know how to write SQL queries. Is it sort of designed around this idea that, like you said, in a regular SQL database, all the data for the most part is there for the queries that you've got to make. In the case of Kafka, it might not actually be all there, right? Like you may ask a query and 2 or 3 of the 10 pieces you need aren't there. Is it designed to handle that sort of expectation that certain things won't be there, but you can sort of manage the fact that that's at the core of it? Or is there something different about, the challenges of querying streaming data, if you will?
That's exactly right. So with a regular database, you kind of assume that you have all the data that you ever will, and you run your query, and then you get your results, and maybe you get some more data and you reinitiate the query, but you're really just scanning the whole data set again and again and again. With stream processing, you actually don't know if you ever have all the data. And this is very much reflective of the real world. You might have mobile apps that are cut off from a network, and then days or weeks later, they're actually transmitting new data. And so there's a necessity in stream processing to be able to deal with out of order data and unbounded data sets. And that's a whole element of the programming model with, how do you define tolerances for how long you're willing to wait for data? How often do you emit updates as your query results change? You kind of give yourself knobs to be able to work with those things in a capacity of making trade-offs. And it really is fundamental to the model and fitting that into SQL.
Gotcha. And so up until this point, before ksql was created, what were people doing to kind of deal with this part of it? Or was this just one of these things where you had to design around the fact that nothing really existed in this space?
This was a really rapidly evolving area. So back in 2015 or 2014 or so, there really wasn't a whole lot going on. There was Apache Storm, which was kind of just getting off the ground, but you really were on your own to design these programs and figure out their semantics and their APIs. And predictably, none of that went very well. And so it took a couple of years for this to really warm up. And a lot of other projects came onto the scene. Kafka Streams is one, which is, again, part of the Apache Kafka project. Apache Flink is another project that does a really great job with this. And there's a couple of others. But yeah, before ksqlDB, if you really wanted to build one of these things, you have to be quite a good back-end systems engineer, probably working with Java and some relatively complex APIs. You're designing programs that are imperatively handling the data and carefully figuring out what to do. You're dealing with a lot of logic for how to start your applications, how to deploy them, and really getting into the weeds of figuring out what does it mean to work with data when it shows up at particular times into particular places. And so this was quite a low level of abstraction. People still do it, but it's obviously not the preferred method for most engineers. People just really want to be able to write their application and move on with their day. And so that's kind of where people have been before a streaming database was created.
Yeah, it's always, the database space to me is always fascinating because we've gone from decades of sort of SQL as the only way to do it to now this explosion. We've got time sequence, we've got GraphQL, we've got streaming databases, we've got NoSQL types of stuff. So it's sort of fascinating to me, the chicken and egg that always happens between a new use case comes along, somebody realizes, well, I could stand a database on its head to do that, but it really wasn't designed to do it. Let's build something that's appropriate for it. And this just feels like kind of the next evolution, given how popular Kafka has been in so many different places.
Yeah, I think it's reflective of how important data has become to different companies and society. We're trying to use data in all kinds of different ways. As you said, the access patterns are changing. We had relational databases for a long time, then we had key value stores and graph databases and columnar and document databases. And now this is something kind of new altogether where it's often the case that you have software that's, there's not really a human at the desk issuing queries to match up drivers and riders for like the Lyft or the Uber app. This is actually just software communicating with itself. And this is really what lends a streaming database to be quite an interesting idea, in that it's reactive, and these streams are actually a very nice lingua franca for different programs to talk to each other.
Yeah. I'm curious, give us a little bit of, sort of timeline and maturity of the project at this point.
Yeah, so the predecessor to ksqlDB was a project called ksql, and that was launched around 2016 or so. And the idea of that project was to really just to provide like a SQL dialect on top of Kafka streams. When you issue these ksqlDB queries, what they actually do under the hood is they compile to these Kafka streams, lower level Java topologies, and they take advantage of all the work that's gone into the Apache Kafka ecosystem. And so that was pretty successful. And then we got to about 2019 or so, and we wanted to do something a bit bigger. A SQL dialect was cool, but you're really just layering on another piece on top of something that's complex. And so how much have you really gained? And so we wanted to look upward and figure out, how do you really achieve this level of simplicity that we've been talking about? And that's when the idea came to us about really getting serious about the abstraction of a database, and investing heavily into the SQL layer, into the query layer, and making stream processing like the flagship feature that would really drive this. And so it's really been running ksqlDB in earnest since 2019.
Okay. And obviously, when you start things, you have certain, kind of use cases or personas in mind. What are a few of those sort of, what you would expect to be kind of common use cases? And have you've been sort of surprised yet by the community coming up with something where you're like, wow, I had no idea, but yeah, I guess that sort of fits.
Yeah, I like to divide the use cases into sort of technical and business. And so the technical use cases that we see quite a lot are, these real-time materialized views that I've been talking about. It's no surprise that people are using that, since that's kind of the thing we put a lot of focus into. And there's a lot of analytical use cases around that. We also see a lot of adoption around these streaming ETL pipelines, which is kind of what ksql's original intent was, where you have this system that sits in the middle of other data storage engines, and you actually just need to change the way data looks as you move it from place to place. This is actually a pretty tricky problem when it comes to streaming, and there's not a lot of great solutions. And so building out these pipelines is really integral for lots of people. And then the last are event-driven microservices. And I think this is kind of the big overall promise of the event streaming world, where you have these systems and applications. They're ingesting events, they're maybe creating some internal state, and then they're triggering side effects. And what they actually do is that they create more events. And so you have this virtuous cycle where events are the currency that everyone's using to transact and to communicate with one another. And so those are really the areas where we see a lot of technical adoption. As far as where we see this in getting applied in the real world, I've seen everything across the industry in like retail, financial services, transportation, and mixes of all the use cases together, which is very cool to see. I'll often see real-time view materialization being tacked on to like the end of a real-time data pipeline. And that's really cool, because you start to see just one abstraction, SQL, kind of handling all of the events at a very high level. And it's very, very gratifying to see that.
Yeah, no, that's very, very cool. And again, it's always sort of interesting to sort of watch the yin and yang between, sort of use case ideas, new technology comes out, expansion of the ideas, expansion of the technology. So very, very cool to watch that. And we will put a bunch of things in the show notes. Obviously, this is a newer topic for a lot of people. We talked about a lot of concepts, and they can get a little bit technical, but we'll put some good things in the show notes for those of you that want to kind of dig in and follow up. Michael, what's maybe some of the best ways for folks, if they're interested in this, either to reach out to you or get engaged with the ksqlDB community and team working on stuff?
There's two great places to go. There's the ksqlDB.io microsite, which has a wonderful getting started tutorial and a link to a really nice set of docs. And so that gets you off the ground really easily. And then our whole team hangs out in the Confluent Slack community. So you can sign up for that for free. The whole team who works on the project hangs out there and chats about the going-ons of the project and answers any questions. And we love to talk to new people. So everyone's welcome.
Yeah, no, that's great. That's great. Well, listen, with that, I'm going to wrap it up. Michael, thank you so much again for the time today. We appreciate you reaching out and introducing to us to something new, which, I think given all the cool things that Confluent works on and kind of the spread of that community, we can expect to see big things from ksqlDB. So again, everybody, thank you so much for listening, as you always do. Thank you to Michael for the time today, and for myself and Aaron. We want to ask, if you get a chance, tell a friend about the show, continuing to help us grow. We are continuing to release Cloudcast Basics for those of you that've got friends that want to learn new things. And with that, we're going to wrap it up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.